Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we are going to be starting our unit on linear and quadratic inequalities. We're going to be doing lesson 1 today where we're looking at linear inequalities in two variables. And so we've been looking at inequalities for a while now in our school careers, but just to kind of refresh ourselves, linear inequalities in two variables can be in one of these following forms. So you could have some variable or coefficient a or b, right? This could be like 2x plus 3y. The a and the b just signify any number. So you have x plus y is going to be less than c, less than or equal to c, greater than c, or greater than or equal to c. So those are the four types of inequalities. And a, b, and c are just any real number, meaning they can be decimals, they can be negatives, they can be anything that's real. Okay, so let's say that we have some inequality like y is greater than 1/2 x plus 2. That inequality that has two variables, in this case we have the y and the x variable, it actually describes a region that's on your Cartesian plane, okay? Now let's pretend that this line represents the inequality we just put over here, y equals 1/2 x plus 2. The ordered pair xy is, and let's make an ordered pair. So the ordered pair that I'm going to choose is going to be 0, 0. And I'm going to explain why I picked that point in a second. If I look at this inequality and I'm trying to pick an ordered pair to test my solution, I'm going to pick a point that's clearly defined and is not near my line. It's not an ambiguous point. And this right here, 0, 0, seems to meet that criteria. It's not near my line and it's clearly defined. And so this point 0, 0 is going to be easy to test. And so when I say easy to test, I'm going to ask myself, does that ordered pair 0, 0, it's going to be a solution to the linear inequality if the inequality is true when the values of x and y are substituted into that inequality. So let's see if it's true. And so what we need to do is we need to plug these into our inequality to test if it's true. So our y value in the ordered pair is 0, greater than 1/2. Our x value is 0 plus 2. 1/2 times 0 is 0 plus 2. And so 0 is greater than 2. Is 0 greater than 2? No. 0 is not greater than 2. So this ordered pair is not a solution for the inequality that we have here, which means that my solution region is this region here. It's the region not on the same side as the point that we picked. So that is our solution region. And one easy way to kind of do this is, and it's not always going to work, it for the most part works pretty well, but here we have y is greater than. If you actually put your inequality, then the greater than region is going to be the region above the line. And so I could have picked a point like 5 and 0 and tested it, knowing that it's probably going to be part of my solution because it's a point above the line, and then tested it, okay? If this were y is less than 1/2 x plus 2, then I'm likely going to be looking at this region below my inequality. And because that's the solution, this solution region is when it's going to be less than, right? And so I keep saying solution region. Solution region is the set of points that satisfy a linear inequality, or it's all the points in the Cartesian plane that satisfy that inequality. And it's also known as the solution set. So solution set, solution region are the same thing. It's the region that's true. Another word you're going to hear me saying a lot today is boundary. And the boundary you can see here is the line that's created when you graph your inequality. So it's the line that's related to your linear inequality. And this line obviously divides your Cartesian plane into two sides. Side 1 above it and side 2 below it. Now for one of those regions, it's ax plus by greater than c is true. That's region 1. Greater than is going to be above. And for the other region, it's going to be less than c is going to be true. And that's this region down here, region 2, where it's less than c. And so your boundary creates two regions. But remember, when you're given a problem, the problem is clearly defined. It's y is less than 1/2 x plus 2. So you're not going to have two solution regions, you're going to have one of them. And in this case, the region that becomes your solution region is going to be region 2 because of, well, we did this problem before, right? Less than and less than. So region 2. And you can test a point to verify that. And so a boundary is a line or a curve, we're going to be dealing with quadratics here soon, that separates the Cartesian plane into two regions. It may or may not actually be part of the solution. And so this is where we're going to have to differentiate a little bit in how we say whether or not what's on the line is part of the solution. And the way we do that is, if it's drawn as a solid line, then those points on the line are included on the solution. And that's going to happen when we use the symbols less than or equal to or greater than or equal to. Okay, so those are going to be the situations. Now, it's going to be drawn as a dashed line when we're trying to say that the points on the line are not included in the solution region. And that happens when it's less than or greater than. And so the difference between these is these ones are less than or equal to or greater than or equal to, and the dashed lines, that means that it's not part of the solution, is less than or greater than. So let's go ahead and try a problem out. All right, hopefully that's enough of a refresher. If you've taken foundations to some other classes, you know that when you're not dealing with real numbers, sometimes you'll be doing stippling, and that's about the extent of possible extensions that we might run into here. So let's try out example number 1. So we're going to be graphing 10x minus 5y is greater than or equal to 0. Now, this is a linear inequality. It's a line. And I know it's a line because my x variable has an exponent of 1, right? Except this is not usually the form that lines are written in. Lines are usually in the form y equals mx plus b, where, remember, this equal sign, I mean, right now we're dealing with greater than or less than or whatever, and that's fine. But we want it in this mx plus b form. That's what we're used to seeing. So let's do that. First, we're going to add 5y to both sides, and that's really all we're going to do in the first step here. So we're going to have 10x is greater than 5y, but we're not quite done, are we? Because our y is not isolated. So we're also going to divide by 5. And this is going to give us y is less than 10 divided by 5 is 2x. So y equals 2x, and we can flip this around, right? If you like me, having your y on the left side of your equation, just start by drawing your y on the left side, and then look at what's happening. The pointy end is facing towards the y, so you just mimic that. And then you put your 2x over here, and I'm going to add the plus 0. So now I'm in slope-intercept form. and my intercept, my b value, is 0, and my slope is 2. And this is enough information for me to actually draw this graph. So I have my intercept, my y-intercept of 0, and my slope is 2, which means I'm going to have a rise over run of 2 over 1. So rise 2, run 1. 2 and 1, 2 and 1, 2 and 1. I'm just going to keep going, get a couple points here. There we go. And now we can draw our line. There we go. Now you need to think about this for a second. So we're less than, is that a dashed line or a solid line? That would be a dashed line, right? It's when it's less than or equal to that this would become a solid line. So we did do this correctly. Now we need to test a point. And we want to test a point that's not on our line. So let's test the point 1, 1 right there. That seems like a good point to test. Let's give that a shot. So our y value is 1 and our x value is 1. So we're just going to be plugging those in. Plus 0. 1 less than 2? Yes, it is. 1 is less than 2. So this point that we picked, this ordered pair of 1, 1 that we picked, which we substituted back into our equation, is true, which means anything else that's on this side is also going to be true. So the way that I'm going to show my solution region is I'm going to shade in anything on this side because these are also solutions. And this is all that you're going to do. So you draw your inequality, you test a point that's clearly visible on one side of your boundary line, and if it's true, that is your solution region. So this region that I've shaded in red is my solution region. That is it for this one. Okay, so it's going to be your turn. Go ahead and try this one out. You are asked to graph and label the linear inequality 4x minus 3y is less than negative 12. This question's in your workbook. Try it out, and when you're done, come back to check your solution. See you soon. Okay, welcome back. Let's take a look at the solution here. So the first thing that I did, you see, is I reorganized my equation to end up with this inequality. Y is greater than 4/3 x plus 4. And I then used my y equals mx plus b format to find my b value was 4 and my m value was 4/3. And I could have picked a point. The point that I would have picked would be 0, 0. And I didn't do this, mostly because I'm used to doing these by now. But let's do this real quick. 4/3 times 0 plus 4 is less than 0. This is going to be 4 is less than 0, which is not true. So this point that I highlighted is false. It's not part of your solution region, which means your solution region lies on the other side, which I have shaded. Now, I also want to take a moment to kind of show you how to use your graphing calculator for this. So let's go ahead and do that. So on your graphing calculator, you're going to hit File, New Document. We're going to just erase things. We're going to add a graph here. Now, we do not want f of x equals, so I'm going to hit the backspace. And when you do that, when you erase that equal sign, it brings up all of these options. Now, we want y is greater than, that's this one, and now we just type in what it is. So it's 4/3 x plus 4, hit enter, and voila, there we go. And you can see that my graphing calculator graph matches exactly what I did by hand. And so you can use this strategy to kind of check your answer as well, because using your graphing calculator takes half a second. Now, can you only do that, then copy it down? No, I need you to be able to show your work. And the work for this isn't hard. Find your b value, m value, plot your line, test a point. It's a very quick process. All right. That's going to be it for this lesson. We're going to move on and try a few more examples in with linear inequalities in two variables in the next video. We'll see you then. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here you will find the next video in this unit. Keep learning, everybody. Take care.